All right, so now that we have finished our two elements, let's make the last one, which is the dust smoke. What I mean by dust is making these trails. I just wanted to name it as a dust. You can call it, you can name it as you know, whatever you want. Okay, let's make another geometry node and make some change the name. I'm gonna call it dust or trail. Okay, we're gonna do exactly same process, but a little different. This time I'm gonna bring our first main smoke sim. So in object merge, just bring that up. So in FX it was out, accept, and name this to in explosion sim, like so. And then okay, and it's point, if you follow this arrow, it's gonna point to our cache and come back to here. And if you middle mouse, we're gonna have density and velocity, right, as expected. And let's split this out. Let's split so we can only see the density. So we see density here, and this second output will be the velocity. So what I'm gonna do is just make some points out of this density. So very simple, scatter, and it's gonna make these points. So right now it's we're having 1,000 points because we set this total count 1,000 here, and I'm gonna leave this, and I'm gonna turn this off, the relax iteration option, because you know we don't have to make a really uniform distanced uniformly spaced particles. I just want random position. So let's turn it off. Okay, we're gonna do some particle sim out of this. So same thing, pop network, connect to here, and dive inside and go to first frame. And this time it'll make error because the emission type is set it to scatter onto surfaces. But before, when we did the other two simulation, we had surfaces, right? But this time we don't have surface. We only have 1,000 points. So we have to change this emission type to points. So let's play it. So it's gonna make particle. So those blue particles are just guides, which is coming from this scatter node. So it's up to you if you want to turn it off on and off, right? But I'm just gonna leave it. Okay, and then go to birth tab. Same thing. I want to make the particles until frame 10, and I'm gonna use this default value 5,000 per second. So let's play. So as expected, it's gonna make particles until frame 10, and then it will stop emitting particles. Nice. Okay, and okay, what I'm gonna do now is I want to once it's emitting particles, wait, basically it needs gravity. So let me add gravity here, and let's play it again. Now it's just going down by gravity. And then what I'm gonna do is simply drawing here. So our main smoke is here, right? Our main smoke is here and ground is here, and we made some scatter points out of this density, right? And then I want to follow I mean, basically I want to make these particles movement like trails as you see in here, right? So how can we make this? So basically I want to make those particles follow to our main smoke movement. So our main smoke is here, right? Let me redraw this. It's really hard to see. And we have a velocity, right? Velocity field or volume of this main smoke. So each voxel has the information of the direction vector. So, you know, here and there it's gonna have some movement of the this smoke. And then I want to have my particles follow by these velocity volume. So if the particles are here, I want to, you know, move those particles by the velocity. So that means the movement of the particles will be same as the movement of the smoke. So we can do this by using the velocity field. Thankfully, we've already saved out our velocity, and then it's coming here, right, in the second output of the display node. So if you're not sure, you just attach the null node and then connect, and see here we have velocity. It's just invisible. So let's connect this velocity to our second input. And then what we can do here is create a pop effect by volume node. This is very useful and cool. And set this velocity source to second input, so second context geometry. And then the field name is vol. You can just, you know, use default name because we're also having vol name. So leave it like that. And then just play it. See? That's really cool. Right? Those particles are following the smoke exactly. Right? So it's very cool. Okay, so here's the thing. So once it's creating, once the particle are, you know, made, like once the particle was born, I mean, even though we added gravity, but it never, you know, fall down. That's just because we are adding this effect by volume node, because that's why it's just following the volume. But let me do this. If we add some condition here, so we can stop using this node at some point. So how can you do that? We're just adding switch node here, and then make another null and just call it just none. And then I'm gonna connect the vol volume to here, and the second input will be the null. So this is very distracting, so I'm just gonna delete this one. So the first input is this one is, oops, sorry. So this one is our velocity, and this one is just nothing, because this is null. And in here, switch node, we're gonna enter a simple expression, which is if the $f is bigger than 10, then it's gonna be true, which is 1. Because now we're on frame 33, this condition becomes 1 because it's true. But if we move our frame to 3, it's gonna be 0 because this condition will be false. So that means we're gonna have velocity until frame 10, and after 10 it becomes nothing, because now we're using this null. Okay, and now we have to reconnect this to here to switch. Okay, and then let's play it again. Now you see it follows the volume. Okay, it's following it very well, but then still, like, if we think of this blue particles as the smoke simulation, it's not really the particle simulation we're doing is not really reaching out further enough. So we have to somehow increase the scale of this initial velocity. So we can do that by increasing this velocity scale here. So just make it 3 times bigger. Now it's much higher, right? It goes much higher. But then the speed of the those particles falling down, like a falling, is too slow. It's almost like a slow motion, right? That's because it has the air resistance by default 1, and this is too much. We need to decrease this a lot. So let's play it again. Now it's following pretty well in the beginning, and then it's naturally fall by the gravity. Cool, right? And if you see the center part, there's some odd chunks of these particles I don't like, and in order to get rid of that, I just simply turn this off, this solve on creation frame off, so that it's gonna calculate this simulation from the second frame. So it's not gonna make any particles in the first frame. Okay, so now it's very cool. Also, it's going down under the ground plane, so we need to make it like we did before. We need to add pop kill and then add some condition here. So same thing. Okay, if the position of the y less than 0, we'll delete it. So as expected, it's gonna get killed once it's go down. Once it's going down under the surface, right? Okay, and then we don't need ground plane here because we added pop kill. And then other things are all same. Let me double check. Okay, here is the last thing we need to change. Okay, if you see my render, the smoke is, it's like making the trail, and then at some point it becomes really blurry. In the beginning, it makes really clear thin line strokes here, but then it becomes really blurry and it dissipates. In order to do that, we need to kill those particles, because those particles will be our source particles. So here on the birth tab, if you go to pop source and go to birth tab, there's like life expectancy. So this means like the particle, whatever particle, the particle will be leave during 100 seconds. So in the pop network, everything calculated by second. So this means 100th second. That means if you multiply by 20, it's gonna the particle will be alive. Am I speaking right? The particle will last for 2400 frames. Okay. Okay, so we need to decrease this a lot. So let's make for example, like just 1 second. So when as soon as the particle gets born, and after 24 frames, and it's gone, right? It's particles. Okay, this is very easy, but I want to make the difference between particles. So some are get killed earlier and others are last longer. So we just use this life variance here. So that life variance is a simple thing. Let me just quickly make some notes here. So life expectancy and life variance. So the total life, the resulting life, will be from that expectancy minus variance, and wait, this is the minimum life and this is maximum life. Yeah, let me delete this. Okay, this is gonna be plus. So if we set this variance to 1, the display is messed up. Okay, so this case we have expectancy 1 and variance 1, so this is gonna be 1 minus 1, so 0, and this is gonna be 1 plus 1 equal 2. So those particles will live until like between these two numbers, so it's randomly from 0 to 2, it's gonna get killed randomly. Okay, so I set this to 1.5 to 1.5, so the minimum will be 0, so some particles will be killed as soon as it gets born, but others maximum they will live until 3 seconds, so 72 frames. Okay, alright, so let's play it. Okay, so some are we're keeping some particles longer, and other particles they are just get killed in the earlier time, something like that. I just wanted to give some variance. Okay, this is very cool, right? So when it explodes, boom, and then naturally fall. Alright, and let's go upward, and let me copy those useful nodes we did before. So we're gonna copy only this part, which is caching part, and just paste here. Okay, and let me just name this to dust source sim, and we're gonna make a dot network again, and this is gonna be our dust sim. Okay, and also we need to copy this pub network, pub object name copy, and paste here. I mean, basically it's up to you guys. Like, you guys can do like cache those particle sim as well, but since this particle sim is pretty fast, I don't want to make this cache node again. I just make sure we have all the smoke simulation cached out. So just keep that in mind. So we have pop object only here, and the result is like these points, and then fall, right? Pretty fast. One more thing, because we were caching the here by decreasing the resolution scale of the velocity volume. So that's why we could do really pretty fast sim up here, because the velocity is not that heavy. So that's another advantage. Alright. Okay, so before we dive inside this DOM network, we need to convert our particles to volume. So let's make another VDB from particle node. Okay, here. And of course we need to make it density volume. And now it's too big. So let's make this to 0.2 and let's make minimum radius to 0. And also, I mean, I should have copied over here, but I'm just gonna do it again. And add velocity, and here V, and change to this. Now everything's set up, and let's make this voxel size double for now because it's too slow. So like before, we have V and density volume like a VDBs, and name it as before source vol. Now let's dive inside this dust sim and we do the same thing. I mean, yeah, you can just copy over other thing, but I mean, you know, there are not lots of nodes, but we have some amounts of nodes and there are tons of different parameters, so it's always good to start with the clean setup. Okay, so this one is resize dynamic and also source, volume source, and we need ground plane and merge them and connect correspondingly and hit L to rearrange, and then same thing, change the first context and then come back to the smoke, and then let me check what number it is. Okay, everything is the same, just copy this density to here, and this time we're gonna use, instead of 0.1, we're gonna decrease a little more, so 0.05, and then hide this ground plane. Okay, and then make this size to 10, 10, 10, and then center will be 5, so it covers enough. And then finally we rename this to dust and copy this division size, and up here we right click, paste to relative references, so we are linked, they are linked. So I don't know why this has some error here. Oh, okay. Oh, that's not a big deal because we don't have any particle, so we don't have any velocity, but we're using velocity here, that's why it complains. But from frame 2 it has the velocity, so it won't complain anymore. Alright, let me just increase a little bit this division size so we can do a lot faster sim. So now its voxel size changes as well. So let's do same thing. Copy this creation object name and go to here and paste, and density just for the visualize purposes, and just play it. Now it's cool, doing something, but it's obviously it's wrong, something wrong. Okay, I forgot to turn off this clamp, and then padding, increase the padding. Okay, that's it, and play it, and it's gonna make much better result. Alright, it's very cool, right? Okay, this is our particle sim. So it's about this size. So I'm gonna make another quick view here, like here, and then Control 8, so I can save the quick view. And then I'm gonna do another flipbook. So let's get rid of this flipbook. And then I'm gonna turn the grid off, and let's do the simulation. Okay, it's very cool, right? Boom. Yeah, we see some cut off here up in the top part, but we're gonna get fix that soon. But other than that, it's very cool. But you might also notice there are lots of like space in between the spheres. You see? So that's because the particles travel so fast, so there's no enough substeps again. So instead of okay, let me wait for this sim. Okay, it's done. Okay, let me hit this button and go to sequence list. Okay, from here, I mean this time instead of this substeps here, I'm gonna do another trick. I mean, it's up to you again. I mean, if you increase this substep here, it basically means it's gonna double everything, whatever node here, like, so it's gonna slow the whole simulation time, really slow down. So it's up to you. I mean, you can increase here, or what I'm gonna do is just I'm gonna add some particle trails, I mean, onto our source particles. So how you can do that? It's really easy. Let me give me some space, and you just put down the trail node and connect, and by default it's preserve original, and it's gonna make, you know, these trails, right? So you can increase the number of particles in the trail length like this. So I set it to 10. And then I wanted to adjust the distance in between these particles. So I can, you know, like a double here. So it's gonna make a much longer line. But on the other hand, I can make shorter. But there's something odd going on, you know, like if I do, it was by default it was 1. But it doesn't let me adjust this distance really dynamically correctly. You see, like I wanted to make it shorter, but it doesn't allow me to do that. That's because, you know, again, we need readtime node. Just connect, and it's gonna do correctly. You see, like if I decrease, it's gonna be shorter, and if I increase, it's gonna be longer. See, that's why we always, whenever you have to deal with substeps, you don't forget to use this readtime node. And I made it really short, like trail increment as 0.1, so this amount is short. That's because if we see like this, That's because if you have if you look at this closely here, like previous frame, next frame, you know, the difference of those points position, it's about this length. That's why because they're traveling and make some smoke, so that's why I made it shorter. I don't have to make it that you know, like longer like that, because anyway it's gonna cover, you know, in between frames like that. So by doing this, I can, you know, save a lot of time in the dust sim, because these increased point number here will be our volume, source volume. So if I don't do trail, yeah, it's gonna make much smaller. But if I do this, it's gonna make a longer trail. So we're not gonna see these dots anymore, like around here, right? We see this like dots and some space in between, but we're not gonna see that anymore because we're covering here. Okay, and then let's do it again. Let's okay, I push this button, so let's do another sim. Make sure go to 8 quick view, and then I'm gonna do this again. Okay, we're still like we're seeing the cutout, but I'm gonna adjust that. Okay, let me compare this with previous one. Okay, if you see here, it's much better because before it has a lot of spaces, but now it's more like thick strokes. This is what I wanted. If you see here, this part, right, much better and smoother. And also, as we have more points on the source points, a lot of we get more volume, so it gets thicker. As you see, the density will be thicker. Okay, I think somewhere here, like it's cutting out, right? I'm not sure where it comes from, but I'm gonna fix that. Let me double check. Okay, I think that was also from because of this initial quick movement of the particle, because on frame 1 it's nothing, but then on frame 2 it's goes that high. That's why this dust sim doesn't catch the bounding box correctly. You see, on frame 2 we already have points here, but in the source it just stays here. So we're gonna do the same thing. We're gonna make the delay frame just 1, so it just to use this initial big bounding box until frame 2, and then this this resize node will take over. Okay, right. Okay, let's do it again. So reset and go to 8, turn off the grid, and then I'm gonna turn off this, hit this button again and capture it again. I mean, it's a little bit, we can just it's much better, right? So we see these extra strokes here, so it's much better. But you know, you can just feel free to increase this so we can get a lot bigger bounding box, but I'm gonna just delay. I'm just gonna leave it as 1. Okay, yeah, this is what I did before. So Okay, finally we just need to make one more change in the dust sim. So go to PyroSolver like we did before, and I'm gonna just make this variance a little bit higher, and also the direction will be the -1. I mean -1. So it's gonna go downwards because this is not a gas explosion. This is more like imagine in the center it's like a gas exploding, so it's mostly going upwards, but in the center here, like the trail smoke, it's more like the piece of the ground smoke, the ground chunks are like exploding, so it's more like a dust, so it'll be heavier than the oxygen layer. So I assume the dust will like go down rather than rising. So because of that, I just set it to -1. And then if you go to combustion, let's turn this off again. And then finally in the shape tab, the dissipation, I wanted to make it last longer, so I decreased this 0.02, and I didn't use the turbulence this time, and I turned on this disturbance, and then leave the default value. And in the disturbance tab, I didn't use the control field this time, but then I reduced this a lot, like this cutoff size as 0.02 and block size as 0.02 as well. So that two parameters, cutoff and block size, is very important. And okay, that's what it does. Is I'm gonna explain you quickly. Okay, so that cutoff, and we have block size, right? So that means, so you can think of this block size as the noise size. So for example, like we have this main smoke, and we want to break this smooth line using the disturbance, and it's basically like breaking the line, meaning it's we're using noise, right? And the noise pattern will look like about like this. And you can just think of this block size is like this size, so the default value is 0.2 meter, so you can, so if we use much bigger block size, it'll make larger pattern. It's like a frequency of noise. Whereas if you reduce this block size a lot more, we're gonna get a lot smaller, like this smaller frequency noise. So that's why I decreased this block size a lot, because this because our dust smoke is very thin, right? Very thin. So this is the smoke source, and we have very thin smoke trails, right? Like a fall. So that's why we don't have enough thickness. We have to reduce this block size a lot. Then we finally see those little noise pattern. Otherwise, if we leave the block size as default, we're gonna see this much larger noise. So this is not gonna keep our trail smoke really dominant. It's gonna mess up. It's gonna mess it's gonna mess up our trail shape. So what I want to do is just to keep this smoke trail thickness, but I wanted to make a little, break the shape at the edge. So that means we need a lot smaller block size. Okay, that's why I used 0.02 meter. And also cutoff is just how much you want to use the disturbance. So that means from the edge. So from the edge, if you calculate the distance from outside to the inside, so the cutoff by default is 0.2 meter. So by 2 meter by this value, it'll disturb your voxels until here. So these volumes will be affected. But from this distance, from here, there's nothing disturbed anymore. So basically the idea was, if we have our volume here, and basically that idea is just to make our outline, only affecting these edges, not the inside. So we break the shape only outer part, okay, not the inside part. So that's why we need a lot smaller value onto these two parameters. Okay, so now that we changed our block size, let's see our result. Go to 8 and hit this button, and then I'm gonna flip book. Okay, we might not see that difference because we don't have enough blocks. We don't have enough division size again, because we need in order to see this disturbed pattern, we need a lot of voxels. Here we need a lot of small voxels. So we need a lot, like lower division size, but we might have to reduce the division size eventually. But okay, this is previously we didn't capture enough frames, so we cannot compare, but just stop and then go to this 31, frame 31, and then compare here. And only difference we notice is just this dissipation we reduced, so it's getting thicker, right? And we don't see the disturbance on the edge really a lot because we don't have enough division size. So okay, let's make this division size as I did. It was it was half. It was 0.15. Also copy this dust node, copy object name, and paste to, we already did, but we need to paste to here, dot fill. Okay, and here we need to change this. It's not wave sim, it's dust sim, right? Anyway, we've just changed this division size really low, and then all you need to do is just caching it out. Same thing. Okay, so just make sure you're merging those two fields correctly. Okay, so it's doubled on velocity, so it's correct. And I'm gonna name this differently, so this is gonna be cache dust sim. And you can just if everything looks good, if you just hit the button and save the disk. But I'm just gonna use my previous sim. I already did again. This one, and let's see. So it's gonna make this nice awesome trails of volume. So if you see, if we go further, we're gonna see the smoke. It's not gonna be emitting the smoke forever because do you remember we killed the smoke? Okay, wait for a second. Because we killed in the dust source sim, we killed our particles much earlier, right? So that's why, and it's gonna affect here as well. So that's why it's not gonna make smoke forever. So that's why the smoke looks, in the beginning it's very thick strokes, but later on there's no more source, so that's why it's just smoke hanging there in the air, and it's gonna be disturbed by the simulation, and it's gonna be like blurred, and it's gonna be naturally like disappeared finally. So this is what I got in here, exactly same thing. Okay, so okay, we're done. All the 3 smoke simulation, and so what we have to do is just we have to just do render. So we're gonna render in the next chapter. So see you there.